So I want you to consider that for quantum mechanics, it's not that an electron's position is in two places at once, or that it's in one place. It's more like it's partially defined. If you look at like how, well, because mass seems like it's spread out over space when you're looking at the atom, and also like when you're looking at the double slit experiment. Yeah, it seems like it's partially defined. And I think we don't think like that because our left hemisphere doesn't like partially defined. It likes it is or it isn't, it will or it won't, even if it leads to a contradiction, and that's like a superposition. So like saying that an electron exists in multiple places at the same time. Uh, a superposition of classical states, that is. We think that the quantum realm should be imaginable, when in actuality we're only making a detection. We can't observe anything. The only things we actually can observe are like the cell structures in a cell. We can't actually see molecules or anything like that directly. It's all scattering events. In fact, you might even say it's not even composed of anything at all. It's just effects. That's a controversial statement, because if it is just effects, what's explaining the effects if it's not composed of anything? And it's probably the previous universe, and all the quantum decisions are being carried over from the previous universe. It's probably an eternal regress. That's the only way you can actually get out of Aristotle's infinite regress problem, where it's like a critique of Plato's forms, which are like physical laws or geometrical laws. And Aristotle's like saying, whatever explanation you invent, whatever domino you invent, there's going to be another domino. It's sort of like that idea that a theist is just an atheist, one God domino removed. So you're not going to, there's a problem, especially in science, where they're trying to get more information out of less information, or something out of nothing. You can see that in all their theories, like inventing a super force, where all the other forces split off from, like a symmetry breaking. But see, the problem is you're just pushing the question back. You're pushing the question back to what's breaking the one force into many forces. Or like superstrings, is you're taking a quasi-orderly, quasi-messy spectrum of particles, and you're trying to reduce it to this perfect thing and expect like something messy to pop out of it. So it's like you're trying to make the situation seem simpler than it is. Same thing with the Higgs, saying all the masses come out of the Higgs goo. It's like, where does the Higgs goo come from, and why does it break up into these other particles? This is kind of like Gödel's theorem. You're really just inventing more things to account for. And speaking of Gödel's theorem, if you look at, like, for example, there was a couple of black high school students, females, that proved that the Pythagorean theorem using trigonometry. And so that's like a mathematical proof. It's like coherency between definitions in the left hemisphere. And well, that's really what Gödel's theorem is. When you say this part of math is coherent with this part of math, that's like a statement that's true, that's outside of the system. So that's what I think Gödel's theorem actually means. So it's not that interesting when you look at it like that. You're just saying there's like these meta statements that aren't coherent or incoherent. They're like talking about the coherency or incoherency of other statements, their definitions. And this isn't invented or discovered. Math isn't invented or discovered. It's like a feature of our either or left hemisphere. Even down to plotting graphs, they're if-then statements. What else? Curt Jaimungal, who has that podcast Theories of Everything, he kind of likens this mysticism, this kind of like unified consciousness push as like the left hemisphere's push for either or, but in a general sense. But what's interesting about that is that Jaimungal doesn't see the push towards unification in theoretical physics in the same way. Trying to, like we were talking about, trying to unify into a super force or unify all the masses into one supermass or superstrings. We got to do away with this notion of unification and see that the universe is distributed effects. They may have a universal format, which I call the grammar of design, but like even that, there's a coherency between all of those. And that coherency arises from the grammar of design too. There's nothing outside of the grammar of design. It even is self-describing. I'll go over that in a future video. It's kind of outside the scope of, first I have to convince you that like physical laws can be redescribed, let alone like a format that can describe itself, Back to that internal regress idea. If you don't have an internal regress, you're going to have a problem like trying to account for like quantum decisions and the constants of nature. We also need to understand like what even, how there's like constant and a variable part of a law. We need to understand what that is in terms of what's its conceptual composition. There's like something that's unnovel within something that's novel. And like I was saying before, like the 1/2s and the squares, you need to have a conceptual breakdown. And all of that has to be, we even have to understand what exponents are in terms of their conceptual breakdown, if we actually want to understand what nature is. It's not unified into like these equations that are either or. And so people like Curt Jaimungal, they mean well, but they're still stuck in the same, where they think nature is the geometrical forms, is the numerical forms. You can see that it's not the numerical forms just by looking at the speed of light. The speed of light could have been any number. It's just a convention. We can shift all the constants as long as their definitions are coherent with each other. So the sentences that we're using aren't actually nature itself.